Good morning, good evening, good afternoon. In this lab entitled Construction of a Density Bottle, what we're going to be looking at is we're going to be looking at a couple of topics that we'll learn about. We'll learn about density, and we'll also learn about solutions. All right, so we're going to be making some solutions, and we'll learn about whether something's miscible or immiscible. Miscible means that the solute will dissolve into the solvent infinitely, it mixes perfectly, or immiscible, which means it doesn't dissolve, it won't make a solution. What we're going to use for this lab is we're going to need our scale, some salt. I happen to use some canning or pickling salt just because we happen to have a whole bunch of it. Our isopropyl alcohol, a graduated cylinder, a couple of test tubes, some disposable pipettes are very handy. We're going to use this what's called a preform. All right, this is basically a Coke bottle or Pepsi bottle or soda pop bottle before it's actually formed into a bottle. And then in here I happen to have placed a bunch of beads. It just seems like a nice convenient place to put some beads. That's what we're going to use for this lab to study the density bottle. Alright, for part one of this lab we're going to determine the density of isopropyl alcohol and a saltwater solution. And what we're going to use for that is we're going to use some salt and we're going to use some isopropyl alcohol. The first thing you're going to do is you're going to want to obtain the mass of your graduated cylinder. And if you already know this mass from a previous lab, don't worry about massing it, just write that down. It's not going to change as long as it's the same graduated cylinder. And what we're going to want to do with this graduated cylinder is we're going to want to put 15 milliliters of isopropyl alcohol into it. So once we've recorded the mass of the empty graduated cylinder, report that mass. Then what we're going to do next is we're going to place in here 15 milliliters of isopropyl alcohol. So I'm going to slide the scale out of the way. All right, and I'm going to attempt to put in 15 milliliters of our and that is about perfect. That's about 15 milliliters. I'm going to take our scale, bring that back. I'm going to wipe off the bottom of the graduated cylinder in case I spilled some on there. And I'm going to report the mass. Now this mass is of the graduated cylinder and isopropyl alcohol. Now on your table where it says mass of isopropyl alcohol, you're going to want to subtract from the mass right here the mass of the empty graduated cylinder and report simply the mass of the isopropyl alcohol. You're going to take that mass of the isopropyl alcohol and you're going to divide it by the volume, which in this case happens to be 15 milliliters. Now that you've determined the density of the isopropyl alcohol, you can turn that back to the original container. Simply because it hasn't been contaminated, it hasn't mixed with anything, and there's no reason to get rid of it. Alright, now the next thing we want to do is we want to determine the density of a saltwater solution. So what I'm going to do is I'm going to rinse out the graduated cylinder to remove any residual isopropyl alcohol, and then I'm going to add 5 mils of water to it. Alright, so I add a little too much, so I gotta dump some out. Alright, I can use my disposable pipette to get it exactly where I want. So now what I've done is I've got 5 mils of water in the graduated cylinder. I'm going to zero out the scale. Alright, I'm going to zero out the scale. And I'm going to now add 1 gram of salt. Oops. Alright, that's about 1 gram of salt, 1.1 grams of salt. I'm going to very carefully pick this up, and I am then going to add this to, move this aside, I'm going to add this to now my water. Alright, I'm going to stir it up, any residual water I have in there. Alright, oops, get that cleaned off. And I'm going to zero out the scale, and I'm going to record the mass of the salt water as well as the volume of the salt water. And now what I'm going to do is I'm going to determine the density of the salt water by taking the mass of the salt water divided by the volume of the salt water. Now what we want to do is we're going to save this salt water, and we're going to use that later on in the lab. Next, we'll work on part 2. In part 2, what we're going to test is we're going to test the miscibility of water and isopropyl alcohol. So I'm going to take a disposable pipette, and I'm going to get 1 full squirt of water. I'm going to place that into the disposable pipette. I'm going to grab another disposable pipette, a clean one right here, and I'm going to get a squirt or a whole disposable pipette of isopropyl alcohol, and I'm going to squirt that into the test tube as such. Now, you shouldn't see any layer in there, because what happens is they're completely and totally miscible. All right. Now that we've done that, what we want to do is we want to add some salt. All right. So I happen to have some salt. I had added off camera into this aluminum foil, and what we're going to do is we're going to add this to our solution here, and we're going to determine what actually happens. And what do we observe? All right. So you're going to want to write down what you observed by doing this portion. All right. And previously, before you add the salt, you want to write down what you observe just when you have the water and the isopropyl alcohol alone. All right. Next, we'll do part 3. For part 3, what we're going to do is we want to determine the density of these high density polymer beads. For the first thing, what we want to do is we want to determine the mass of 20 beads, because the scale you have is not sensitive enough to measure 1 bead. If you want a scale that sensitive, it would be much more expensive than the one I had you purchase. So now what we're going to do is I'm going to count 20 beads, and we're going to determine the mass of those 20 beads. So I happen to count off camera 20 beads, and this happens to be the mass of those 20 beads. And in your table, what you want to report is, in the table it says mass of 20 plastic beads. You want to determine, or you want to record that mass. All right. You'll take that mass and you'll divide it by 20, and that will give you the mass of a single plastic bead. So now that we have the mass of a single plastic bead, we need to determine the volume of a single plastic bead. We're going to take that mass of a single plastic bead and we're going to divide it by the volume of a single plastic bead. But in order to find the volume of a plastic bead, what we're going to do is we're going to submerge them in isopropyl alcohol. So we're going to take a graduated cylinder and we're going to add 5 milliliters of isopropyl alcohol to it. All right, oops, I sort of overshot it. So I am going to take some of that out. I need to take just a little bit more out. All right, that should have done it. Yep, all right. So we are now at 5 milliliters. Sorry, it's very difficult to see. And what I'm going to do is I'm going to count out 7 beads. So there's 2, 4, 5, 6, and now 7. So I have 7 beads. I'm going to report this volume, which should be about 5 milliliters. Okay. I'm going to add to that the 7 beads. Notice that the beads sink in isopropyl alcohol. All right. And the volume has changed. So it's gone from 5 milliliters, or whatever your initial volume was, to a new volume. All right. The difference in that volume is going to be the volume of 7 plastic pieces in milliliters. So you want to report that number in the table under volume of 7 plastic pieces. Not this volume, but the difference in the initial volume and the final volume. You're going to want to report that. You now take that volume, the difference between the two volumes we just had, and you're going to divide it by 7 because that's the number of plastic pieces you placed into the graduated cylinder. You're going to take that volume, the difference, once again, divided by 7, and that's going to give you the volume of a single plastic piece in milliliters. Now, to determine the density of these polymer beads or these plastic beads, you take the mass of a single plastic piece and divide it by the volume of a single plastic piece, and that will give you the density of just one of these high density polymer beads. All right. Now on to part 4. All right, for now part 4, we're going to do the exact same procedure, but we don't need to care about the density of the beads. What we're going to do is we're going to determine whether these beads float in isopropyl alcohol. So we're going to get our isopropyl bottle. We'll put that into a graduated cylinder. The volume of it actually doesn't matter because we don't care to determine the density of the beads. All right. And so now what we're going to do is we're going to place the beads into the isopropyl alcohol, and do they sink or float? We'll notice that they actually sink. All right. And as such, we notice that they actually sink. They do actually sink. All right. And so we want to report that. All right. So that will be in part 4. All right. For the second part of part 4, we just got done seeing whether the beads float or sink in isopropyl alcohol. We notice that they sink in isopropyl alcohol, but we already knew that from part 3. Now in this part, what we're going to do is we're going to take some water and we're going to add some salt. We're going to determine whether the beads float or sink in salt water. All right. So we take a little bit of water here. So I have some water here. I'm going to add a little bit of salt to our water. All right. So add a little bit of salt to the water. I'm going to mix that up as such. Make sure I get all the salt in there as possible. Now I'm going to add some beads to the salt water, and notice what happens. They float. So we want to write down that observation. Now this gets us to the end of part 4 and on to part 5, where we will be building a density bottle. All right, now we're on to part 5, the last part of this lab. To start out with, what we're going to do is we're going to measure 2.2 grams of salt. All right, so measure 2.2 grams. All right, there we go. Okay, we're going to set that aside. All right, so we just sort of set that aside. We're done with our scale. Now what we want to do is we're going to add 10 milliliters of water. All right, there's our 10 milliliters of water. All right, and we're going to take our salt. We're going to add that, okay, to our water. All right, so that should be pretty good right there. Now the volume of this is going to increase because the salt water is going to so the 10 milliliters of water with the salt makes the volume greater than 10 milliliters. All right, now you're going to take your disposable pipette and you're going to remove some of the salt water such that you have a volume of exactly 10 milliliters. All right, so we have now a volume of exactly 10 milliliters. And I'm going to take this now and I'm going to put this into my preform as such. Right, so I'm just going to add this to my preform. Right, this is your preform, and I'm going to put the lid on it and I'm going to set that aside. All right, next what I'm going to do is I'm going to now rinse off the graduated cylinder, and I'm going to add 10 milliliters of isopropyl alcohol to it. All right, and I'm going to shake that such that it's fairly dry, and now I'm going to add 10 milliliters of this. Oops, I'm making a mess. All right, that's 10 milliliters. I'm going to take that and I'm now going to add it to my preform as such. All right, and that's going to form an emulsion because they're going to separate. Now to see it, if I place a few beads in there as such, all right, and I shake it up, what we should see is the beads should move. All right, as this emulsion separates, the beads will eventually settle down to a certain level. All right, it may take some time depending on, so you can see that they're actually starting to move down just a hair. All right, so this is the conclusion of lab construction of a density bottle. I was going to tell you one thing about the disposal. Be sure that you don't put the beads down the drain because they can actually clog up sinks. So you want to make sure you dispose of them in the trash. All right, if you have any questions, feel free to let me know.